Good morning, fourth graders. This is Friday, January 15th, and we are continuing to learn about the eye today. So far you have talked about the parts of the eye, the different functions of those parts, how we see things upside down, and so on. So today we're going to kind of review those things. We're going to watch a brain pop video together. And then you're going to tell me or your teacher, we're going to go through the order in which the eye functions. So how we get to see things. And I'll walk you through your assignment today and talk to you about that. So let's start off by watching this video together. And if you need to refer back to it after we're done to help you with the assignment, you can do that as well. So.
Ooh, old-timey photographs. How much? $5. Well, you got it. I don't believe this is the only costume you had left. Dear Tim and Moby, how are our eyes able to see stuff? I don't get it. Sincerely, Fausto. Well, believe it or not, your eyes work kind of like a film camera. Light tends to move in a straight line unless something reflects it or bends it. When light hits an object, it bounces off and is reflected into your eyes. Your eyes have their own light-bending parts called the lens and cornea. The cornea is the outermost part of the eye. It collects all the light that's bouncing off of objects and focuses it through a small hole. That's your pupil, the black spot we all have at the center of our eyes. The iris, or colored part of your eye, opens and closes around the pupil, depending on how much light there is. If it's dark, the pupil will open up wide to let in as much light as possible. Whoa. Right behind the pupil is the lens, which focuses light onto the back of your eyeball. The lens is clear and curved, and it can change its shape depending on what you're trying to focus on. It acts a lot like the lens of a camera. The back of the eye is coated with a special layer of tissue called the retina. The retina is kind of like the film in a camera. It's covered in photoreceptive nerve cells. Oh, photoreceptive just means they're sensitive to light. Anyway, there are two kinds of photoreceptors on the retina. You've got about 6 or 7 million cones and more than 120 million rods. Rods are very sensitive to light. In fact, they can be triggered by a single photon. The cones are less light sensitive, but unlike the rods, they can detect color. No, I am not posing for color pictures. So the lens projects an image onto your retina where the rods and cones transform the light and color into electrical impulses. These are transmitted up your optic nerve and into your brain. There, your brain decodes the image, and that's how you see. Right, there's another way the eye is like a camera. When a camera lens focuses an image on film, it winds up upside down. And when the lens of your eye focuses an image on your retina, it also turns upside down. But when your brain processes the image, it flips it right side up for you. If that didn't happen, well, you'd probably fall down a lot more often. I'm glad you asked. Humans have pretty good vision, but some animals can see even better. Raptors, like eagles and hawks, have eyesight 10 times as sharp as ours. They can see their prey from 1,000 meters up in the sky. And believe it or not, the eyes of the giant squid are a lot like ours, with millions of rods and cones. Okay, can I have my photo now, please? I want my $5 back.
All right, so that was, let me go back here. That was basically the process of how we see things, okay? And the steps that it takes for us to be able to process those light rays into our eyes and for our brain to kind of decode that message that all of the parts of our eyes are taking in and sending to our brain, and how we see things. And it's kind of cool that they mention this too, how it's very similar to film cameras, right? When we take in the light at first into our cornea and through our lens, the image that is projected onto the retina, onto the back of our eye, is upside down, right? Only after those photoreceptive cells, those rods and cones in our retinas, send that message through our optic nerve and into our brain. Only then our brain is then decoding that and flips that image back right side up for us, so we see things the right way. So today what you're going to do is you're going to go into your Google Classroom and you're going to open up your science exit slip today, okay? And you're going to open this up. It should be titled, now mine's a little bit different. I had to put my name at the beginning of it, but it should be titled Steps of How We See, okay? Now this is different than our normal Google Forms that we're used to answering, because you're going to be answering this in order, right? So what happens first, what happens second, third, fourth, fifth, and last, okay? So you're just going to pick what you think happens first, right? So which happens first? Get off of this so you guys can see this answers a little bit better. So light beams from the sun or other source of light reflect off objects. The image then sent through the optic nerve to the brain. This is where the image flips upside down, or light catches the color of what it hit. This forms a shape with many colors. So you're going to click which one you think happens first in the process of us seeing things. Now once you hit that, you go on to your next one. What happens second? Read the choices and then pick what happens second in the process, and so on. So you're going to pick the third stage, the fourth, the fifth, and then the final stage, what happens last, okay? So if you need to refer back to this video, once it's over and you're going over your exit slip today, you can go back and listen to the video with me again and watch the brain pop to kind of get a hang of it if you want to get the information that you need, and go back and answer the question that's left in your exit slip. All right. I hope everybody has a great rest of the day. We'll see you in a little bit for math.